All right, we're back. We're on page 55 of Math Analysis. We're in Notes 5. This is the last page of Notes 5. Then I guess we'll be on Note 6. But let's see what we can do with this. So hopefully the last problem has motivated you to think about what would happen if you had just a table of data instead of a graph. So really, if you just have the data, what are you going to do? I think what you're going to do is create a scatter plot. Because once you have a scatter plot, you have a really good idea of what's going on. You can see what's happening. So what I'm going to do is I'm going to do this first problem by hand, and I think show you how to do it on the calculator, or at least how to create a scatter plot, how to check your answers, graphically at least, because the easiest way to check your answers, to find the function on the calculator and just plug in, -4, -2, 0, see if you're getting the right answers out. If you are, you got it right. There isn't only one answer to these questions. There's an infinite number of answers, but additionally, like we're going to take the most obvious thing. It's possible to come up with like a shorter period that will go through these points as well. I'm not looking to do that here. I'm looking for like the most obvious thing. So let's see what we can do. So by hand, I'm going to make a scatter plot here. Doesn't need to be perfect. Just needs to be like pretty good. So it looks like we're going by twos. So I'm going to say this is like -4, 0, 4, 8, 10. So I don't know why I spaced it out like I did, but I did. And then I don't really care about the y-axis. All I care about is the relative position. So I need to go like, let's say here, and then down here, then back here, up here. So I think I see what's going on here. The scatter plot can help you to make sure that you're actually seeing the trends that you think you're seeing, because you kind of never really know. So this looks, my hand is like sticking. That looks pretty good, right? That's definitely a trig type thing. So what are we thinking here? I'm thinking, based on the table, that my maximum is 5. I'm thinking that my minimum is -3. And I'm thinking that the sinusoidal axis is actually 1. So we were really given all the information that we needed. Furthermore, to go from a maximum to a maximum, I would need to go from 2 to 10, which means it takes 8, right? So it looks like 8 for one full period. And so I'm pretty set. Let's collect our info, right? So the period we think is 8, which means that 2 pi over b is equal to 8. So b is pi over 4. We think the sinusoidal axis is 1. We think the amplitude, because you can go up 4 or down 4, we think the amplitude is 4. We don't know if it's positive or negative, so that's the absolute value of A. And then we have a bunch of starting points. So I think when you're doing this, it makes the most sense to just kind of like start at the start. So I'm going to start at -4, say that's a negative sign graph. So let's see if we can do that. So if I start at x equals -4, then my function f of x should be a negative sign graph. So -4. Let's do 1 minus 4 sine of pi over 4, x minus -4, so plus 4. All right, move 1 over to -2, which should take me to negative cosine, and it does. So that makes sense to me, because I was thinking that would happen. So f of x is 1 minus 4 cosine. So what we're going to do when we check it is I'm just going to, like, if you get one of them right, I'm going to kind of assume that you get all of them right. Alternatively, you could graph all of them. That's probably the easiest way to check a bunch of graphs. So it should be, if I start at 0, positive sign, which looks like it is. So 1 plus 4 sine pi over 4 x. I still write minus 0, even though you obviously don't need that. I think that it's a good habit to have. And then 2 should give me like the last one that I need. So f of x should be positive cosine. Cosine of pi over 4 x minus 2. Okay. So I think that these are all the equations that I want. And you can kind of see that if you start at 2, you definitely get a positive cosine based on what we did. So I'm going to go to the calculator. I'm going to create a scatter plot, which is something that we've never really done before. I'm also going to graph these and then check them. I don't know, a lot of things. So let's go to calculator. So here, I'm going to do I'll do a new problem, doc for enter, right? That gives you a new problem. And then graph page. So actually, I really want to start with listen spreadsheets. So choose option 4, and then I need to arrow up next to the A. I'm going to type XC for X coordinates, and then press tab, and then YC for Y coordinates. I don't actually know if you can see this whole thing because it was like off to the side. So I'm up here, I typed XC, I typed YC, and now I'm going to put in the things. So the X coordinates are -4, -2, 0, 2, 4, 6, 8, and 10. So, and that's totally fine. A faster way to do that, by the way, is to do equals SEQ -4 plus 2t, comma t. I want t to go from 0 to, I need to get 10, so I need to add 14, so 7. Like this, overwrite it, sure. And it does it all in like one shot. And you know, you can never tell the difference. So that's if you had to do like hundreds of them. There's no way you want to type those in. All right, 1, -3, 1, 5, 1, -3, 1, and 5. So now I need to create my scatter plot. So I have this in listen spreadsheets. I'm going to do doc for and insert a graph page. It's got to be in the same problem. And now I'm going to press menu and option 3 for graph entry edit and choose option 6 where it says scatter plot. So what I need to do is I need to tell it what the X coordinates are. But if I press vars, I can see they're just stored there. And vars to get the Y coordinates, press enter. Here is a much better scatter plot than the one that we made because it's totally accurate, right? It uses all the values. So let's see. Let's change it back to function. So menu, option 3, option 1. And then I'm going to graph one of my equations, 1 minus 4 sine of pi over 4 quantity x plus 4. Enter. And you can see it goes through the points, which is awesome. Like that's what we want to happen. So you can keep checking them, or you could be like, yeah, I definitely got it right. Whichever of those, apparently I'm going to check at least one more, and it still goes through the points. And that's like a really cool way to check, create your own scatter plots. So you can do something where the calculator tries to give you the equation. So I'm back in the spreadsheet. So I was like control to the left, or you just arrow over and click it. If I go to menu and then I go to statistics and then I do stat calculations, I know that it should be a trig function. So one thing I can do is sinusoidal regression. I like don't really know all the math behind this. I do know that I need to change the X list to this, press tab, press to the right, change the Y list to this. This iterations thing, I don't exactly know what that means. The other thing that's going to happen that's kind of a problem here, let me just press enter, is that everything is a decimal. And so there's kind of an issue where it changed pi over 4 into this. You can check, do equals pi over 4 with a decimal, and see, like, it got it. And it tells you this, and it shows you up here what the equation should look like. A times sine of bx plus c. So it doesn't use transformational form. So you do have to think about that a little bit. And then plus t. So it'll do it. It's all decimals. So it's kind of like useless if you want exact values. But still, I mean, very handy. Just, you know, not useful for exact values. But anyway, I'm going to go back to the notes. I think we did a good job on this. So I'll probably end the video here because it's kind of a lot. And then come back and maybe get these done. I don't like the looks of set 3 here with all these decimals. But they look like they're by eighths or something. But anyway, I'll be back in the next video. We will do one or maybe both of these, and I will see you there.